Okay, so today we're going to connect to a database and we're going to use SQLite. SQLite's kind of perfect for our use case here because we don't want to store that much information. Really, we just want to keep track of the hash of a file and then the different locations where we see it. So something like SQLite is really good. We don't have to run all of Postgres or any other database application. SQLite is essentially just a file, an SQLite file that will sit in our directory. So this makes it really, really easy for us to use and a really good use case here. So we're going to make use of Matt N's Go SQLite 3 package. So you can find that here, github.com/mattn/go-SQLite3. And there's some good documentation here. So this is the documentation on the Go site. If we expand that, we have installation here. And in his GitHub repo, there's a lot of examples. So this simple.go example here has everything we need. It is a CRUD DB thing. You've got setting it up, writing, reading, deleting. What did I miss? Updating. Yeah, so we've got everything we need in this example file here. So what we'll do is we'll install SQLite, this SQLite package in our existing application. And then we'll just take a look at creating a test table. We'll test writing to it. And then maybe if we get time, we'll start writing our images to it. And then later we'll look at a more optimal solution for our application. But let's just get started adding SQLite 3. Cool. So first thing we need to do is run this command here. So let's go to our directory image sorter, and let's open up our program here. Actually, sorry, before we do that, we need to actually run this command. So go get and then the GitHub address here. So let's run that. Now this will go and download the module, download the package, sorry. And here you can see that it's downloaded and it's added this version here. So we need to keep this here because this is what we're going to import as well. So now we can open up our program again. Now we can import the package here. Let me just get rid of this go get. And we need to import it with this underscore before it. Now this is a little bit weird. And the reason that we do this is because we want to use this a little bit differently. So here when we import format, for example, we want to use it directly. So that's why we have it here. And then we'll use format.println and so on. This package is a little bit different. So this is a database connector. So when we import it like this, it will run the init function of this module. But we don't actually want to use this directly. We're not going to use like go SQLite.connect or whatever. Instead, we can use these SQL commands. So here, this SQLite 3, yeah, this is the connection that we're opening and is created here. So yeah, now that we have that imported, let's go through this example here and start adding that to our database and kind of look at each of these lines as to what are they doing and why are we adding them. So os.remove. Now, this is deleting a file. So let's go down to our main function, and let's do it after the arguments because I think later on we're going to make this a bit nicer. But once we have all the arguments sorted, that's when we'll start looking at the database. So clean up previous database. OS remove foo.db. Do we still call it foo? Let's just call it image, sorta. Now, a big question we're going to have later on is, do we want our database to persist? We might want to keep it even after the program's finished and kind of use it as an index for the directory. But for now, just because we're going to be doing a lot of playing around, let's remove the old database each time, just so we can, have a clean slate every time we run the application. Okay, so now we want to open the connection to the database, and we give it the database connector, this SQLite 3, and also the actual database file. So here we've just removed the old one. As you can see, this is creating it again. So let's copy that in. Let's type it out. I like to type things out because then it really cements it in your mind. After you've gone through the muscle memory and kind of forcing yourself to go through the process, it really helps it to stick in your mind. So I really recommend that. I might make available this whole project as a Git repo. But if I've done that and you happen to have access to it, I still recommend really just typing it out yourself. Don't just copy and paste it, because it'll really help to cement it in your mind and just get it into your muscle memory as well. So what do we want to do? We want to connect to SQLite DB. So again, I've already forgotten the command. So typing this out is really going to help. So we call it db as the variable. Whoops, BS. db error, and then we want to use this SQL open. SQL open. First we take SQLite 3, this connector here. SQLite 3. And then we'll give our DB a name. So let's call it image sorter DB. Okay. Actually, just let's just comment out this remove line. So the DB does stay there, because then we can see the file sticking around and we can see how SQLite works. So okay, let's handle the error. So if error is not nil, then log fatal error. So the same way that we've been handling errors this whole time, we can handle it this way. And then similar to when we open a file, like we did in a previous video, we can defer closing the database connection as well. So let's do that. Defer db close. Great. Okay, so this should create the database. Let's just run this. Let's just run this and see what happens so far. So we should add a comment here as well. So recursively hash files. But let's just comment that out as well. We'll handle that all later. Let's just focus on the database. Okay, so go, whoops, can't type today. Go build our application. Okay, declared and not used source directory. Okay, yeah. So, yeah. Go is really strict on if you use assign a variable, you need to use it. So in a way, this is really good. Uh, it makes sure that you clean things up and don't import things or create variables that never get used. So I kind of like that about Go. It keeps things nice and clean. So let's just chuck that in um, just to make sure that variable is used. Undefined SQL. Okay, so we need to sort that out as well. SQL. So okay, sorry. So we do need to actually import that as well. So database SQL. Let's import that database SQL. Okay, cool. Right. So now we should be okay. Go build. Good. Okay, we've built it. Now let's take a look at our directory here. So we've got the exe file that we've built. We've got the original source code, and then our other Go files, our README file, and our photos directory. Now, if we run image sorter, let's just run it with the directory. So we get that directory output there, just because we needed to make use of the variable. But if we list out the directory again, okay, it didn't create the database. That's interesting. So I was expecting to see this database file here that we just called image sorter.db. I was expecting to see it in here, but it looks like it hasn't actually created it yet. So, yeah, okay. So it looks like there's another command that will create it. That's yeah, that's interesting though. Um, okay. Um, yeah. Okay. Let's try the next step then and see if it gets created here. If it doesn't get created here, then we've got some kind of bug that we need to fix up. Um, so this here, we're going to add a SQL statement. So let's go back to our code and down to our main function. And let's go to the next step. So SQL statement, uh, let's just for consistency call it the same thing as in the example file. This will help us with debugging later on. And okay, so it looks like we assign it using a backtick here. And then that's when we can write our SQL code. So here we're just creating a table. So create table, and let's call it files. And then we we define what that table looks like. So we've got an ID integer not null primary key, ID integer not null primary key. So if you haven't worked with databases before, then what we're doing is we're setting the table is going to have a field, so like a row in the database called ID. It's going to be an integer, so it will store 0, 1, 2, 3, or will it start at 1? I think it will start at 1, 1, 2, 3, 4, 5, 6, 7, 8, and so on. Not null means it can't be empty. There has to be a value in there. primary key. So this is the primary identifier for that table. So these must be unique, these ones here, and this is how we can we know that we're getting a unique value in a unique row. So name text. So that's another field. So name text. So we've got two fields here. We've got the ID field and the name field. This name field is just a text field. It can be empty, but yeah. So text is the type here. Okay, then for SQL we close it off with the semicolon. Delete from foo. Let's leave this part out. Um, yeah, let's leave that part out. Let's just create the table and then execute that. So it looks like this is how we execute this statement here. We use the db_exec command. And then in the similar Go style, it returns two values, and we do the error handling this way. So we don't need to make use of this variable here. We just want to execute it. If there's an error doing that, then we'll use this to print out some of the details as to what went wrong there. Okay, so okay, let's do it. Let's type it out. So we've got nothing here, so we're not going to make use of that. The error here, and then this is where we run our db_exec. We want to run the SQL statement that we've written above, and that is it. So if error is not nil, then we'll handle that error. So here we are going to use, we'll use our log statement and printf, so formatted print statement. We'll use %q. Let's come back to that. And %s, whoops, s, new line, and then we'll pass in the error and the SQL statement. Okay, so that's nice here. So this %q is formatting for this error here. This %s is formatting for this SQL statement. So the SQL statement is a string. It's this string that we've written here. So that just formats it as a string. Now %q. So yeah, a double quoted string safely escaped with Go syntax. Okay, so it looks like it chucks double quotes around it and then escapes it. Why we need to do that, I don't know. That's what it's suggesting here. So let's just do it. Okay. Then yeah, let's just return after that. We kind of don't need to because nothing else happens in the program after this. But if we bring back this this function call here, then yeah, then this will stop that from running. But yeah, okay, let's just compile it. Oops. Let's just compile it and run it. So go build this. Oh, okay. No new variables on the left side of the assignment. So what, line 67. 67. What did I do wrong there? That's oh, is it because we're already using? Yeah, we've already used the error variable. So yeah, okay. Yeah, so you can only I mean after you've assigned it the first time, it's already given a type. So yeah, so you don't need to do that again. So let's build our application, go build, and then let's run it. So image sorter exe. And then we get this error here. Binary was compiled with cgo enabled equals 0. Now, cgo, yeah, so cgo allows us to run C code in Go. C code enabled equals 0. This is, so yeah, so this SQLite 3 package is going to require cgo to work. So it must be calling C code to connect to the database. Now, I don't have a C compiler installed, so we're going to have to do that. Depending on your system, it's going to be different. If you're on Linux, it's probably going to be a lot easier. Here I am on Windows, so um, recommend Googling how you're going to install it. If you're on Windows, I think we can use Cygwin. Okay, just an interjection here. So I'm about to go on a very, very long path of installing Cygwin and a C compiler for Windows. If you're not on Windows, I'd skip to the end of this part. I'll put a timestamp in there so you can skip straight to it. This is going to be installing a C compiler on Windows. If you're on any other system, skip this because you're going to get bored. Just skip it. Work out how to install the C compiler for your system, and then come back to the timestamp. If you're on Windows and you already have a C compiler, also skip this. This is if you don't have one installed. If you want to do it differently, do it differently. If you've got no idea what you're doing, then follow what I'm doing exactly. Okay, you've been warned. Please skip to the timestamp if this isn't relevant for you. So go to cygwin.com, install Cygwin, and run this setup Ep.6 exe. So let's run that. Okay. Run anyway. Cygwin is a very well-known application. It's trusted, but obviously make sure you're going to the right address. Make sure you're downloading it from the right place. Please be safe out there. So install from internet, Cygwin, let's install it for all users. Local package directory, let's change that to Cygwin packages. Yes, create it. Okay. Choose whatever makes sense for your location. Let's see, I'm in Australia, so is there an Australian one? Internode is in Australia. Next. Okay, so here we are. So you can install a bunch of packages here. What we want is a C compiler. So is there GCC devel? Yeah, so this one here, GCC core. All right, let's use this one here, this MinGW-w64. So we'll get the 64-bit. GCC core here for C. So let's get latest stable version. Hit next, and then next, and this will download that. So let's just wait a while for that to download. All right, so let's add it to the start menu. We don't need a desktop icon. Okay, so now that we have that installed, it's going to install it's going to install a lot of different applications here, a lot of different commands that are often available in Linux, but not in Windows. So if we go to this directory here, the Sigwin64 directory, in the bin directory here, so bin, here we see a whole bunch of different exe files. Now the one that we want is this one here. This is the C compiler. So yeah, we can grab that, and we could run it like this. So fatal error, no input files. So yeah, obviously we need to give it a file to compile. But what we want to do is add these to our environment variables. So environment, where was it? Edit the system environment variables. We can add this in here, environment variables. Let's add it here, new. So we essentially want this directory here. So you see, Win64, and we want to give it the binary directory. Okay, done. So I think we're gonna have to restart our terminal or PowerShell, and now, okay, so now we can access it. So that's good. All right. Now that we have the environment variable set, we do need to do one more thing. So if you've been following me exactly, Go is going to be expecting the gcc.exe file. So we don't have that. So if we go in, well, not there. If we go to the Sigwin, to the binary directory, and here, this is the GCC file that we have. So Go is going to look for this, just gcc.exe. We have the full thing here. So what we need to do is make a symlink. So cmd cmk link h gcc.exe, and then this one here. So here we're making a symlink to this exe file here. Sorry, hard link. Okay, so now if we run GCC, it works, right? So it's linking to this file here. But yeah, now we have it there. So let's go back to our Go directory. So where are we? We're recording, yep, and then dev image sorter. All right. So what's the other thing? I just had a note. We have to ensure that we need to ensure that the environment variable is set. So this env cgo enabled 1. Okay, so Let's check that. Go EMB CGO enabled 1. All right, good. So GCC is there. Obviously we haven't given it any file, but it's there, it's working. We have CGO enabled. Now we can build our application again. It's taking some time. Okay, now that's done. Let's run our application. So image sorter. Okay, so it looks like it ran okay. We didn't get an error, so it seems like it executed the SQLite command, and now here we can see the SQLite DB has been created. So we're making progress. We're making progress. So originally my intention was that we would connect to the database, we'd create a table, and then we'd write to that table. But we had to take a bit of a detour getting everything set up. So I think we'll come back with another video, and then that's when we'll look at actually writing to that table, reading from that table, deleting. We'll do all the database things in the next video. I hope you've been able to follow along okay. This is very specific to Windows. I chose a very specific setup. Your setup could be different. I think now that we've got a C compiler installed, we can use this package. So now it doesn't matter what system you're using, whether you're on Linux and you've got GCC installed in your environment, if you're on Mac or whatever. The main thing is you just need GCC installed so that the Go application will build the Go SQLite package. So sorry we didn't get to everything in this video. In the next video, we'll look at those database operations.